Right, there's 6 questions of this common test. It's actually pretty straightforward as long as you are able to interpret all the data given to you. Before we begin, need to remind ourselves that okay, now if we know that PA is 0, that means that x minus a is a factor. Right, this is virtually the factor theorem. And so let's begin by looking at information about AX. It's given that AX has a remainder of this 3 minus 2x when it is divided by this expression, and you when you divide AX by this, you get a quotient. We do not know what it is, so we represent it by QX, and the remainder is 3 minus 2x, x squared plus 3x plus 2. And if you multiply the whole equation across by this quadratic expression, you end up with this. Again, we do not know what is QX. This doesn't really matter, right? And it is given to you what PX is. The PX is AX plus BX. And what is AX? AX is this one. This is AX and this is BX. So we're going to use this theorem to help us to show that x plus 1 is a factor. So assume that a is -1. If we can show that p to -1 is 0, then we can then conclude that x plus 1 is a factor of px. And so what we need to do is just do this. Okay, again, we don't know what's qx, doesn't really matter. You realize that it's not important for us to know what qx is. So we just replace x by -1, and you probably now realize that this is actually what? This is 1 minus 3 plus 2, this is 0. Right, so the whole term here is going to be equivalent to 0, and this is 5 plus what? What is b minus 1? Now b minus 1 is -5, so this is 0. And by the factor theorem, we can then conclude that x plus 1 is a factor of this polynomial. Voila.